Hi everyone, my name is Reza Rahman. I'm Principal Program Manager at Microsoft. I essentially work on our Java portfolio. That means working on a bunch of different things to better serve Java developers on Azure. In particular, obviously, I've been involved in the Java EE, Jakarta EE community for a little while, so I do focus a bit on that. And I'll actually, the talk I'll be doing today is pertinent to that. It pertains to a lot of the work that we're doing alongside vendors like IBM and Oracle. We're making sure that the application servers that they have and the runtimes they have in support of Jakarta EE and MicroProfile developers all work extremely well on Azure and specifically on Azure Kubernetes service. So actually, the talk I'll be sharing today is a lot about that. Right? So the title of the talk is Effective Kubernetes for Jakarta EE and MicroProfile developers. What that means is I'll be showing you some key things to consider while you're using these APIs with Kubernetes. There are some specific nuances, and believe it or not, vendors like IBM and Oracle are doing quite a bit to make sure that their runtime support Kubernetes extremely well. And you'll see that for yourself in just a second. So this talk has absolutely no slides whatsoever. Instead, what I'll be doing is actually showing you code and showing you how things work and explaining the trade-offs as we go along. There's a number of topics that I'll be talking about. In fact, what I'm going to share with you is not any kind of slides whatsoever, but rather a GitHub URL. The GitHub URL is here. As you can see, github.com/ that's my account name, and the repository is called Jakarta EE-Kubernetes. So this actually is structured as an 8-hour lab. So if you were to do this, follow the instructions on this GitHub repository from end to end, it'll take you about a day. Obviously, we do not have a day here. My objective here to show you some key trade-offs and to familiarize you enough with the contents of this GitHub repository so that you can go ahead and take a look at that in a bit more detail on your own time. Okay, so that's the objective. It's just sort of giving you a high-level overview of what this content is so that you can dig in a bit later on your own. So some of the trade-offs we'll be talking about are things like this. So I'll be showing you a little bit about how sort of this on-premise model of application servers and these runtimes work when you're talking about in a Kubernetes environment. So how do things like server administration, clustering, auto-scaling, auto-discovery, load balancing, etc. work in a Kubernetes environment? They work slightly differently because the application server runtimes are tailored towards making all of those things work well in Kubernetes by taking advantage of the functionalities that Kubernetes provides. We'll also be talking about a little bit about how to use so-called Kubernetes operators. If you don't know what those are, I'll explain them in a moment. You don't have to use Kubernetes operators, but all of the Jakarta EE runtimes and MicroProfile runtimes, for the most part, provide you Kubernetes operators, and they definitely add some additional functionality that you normally do not see. So the things that I won't have time to talk about too much, but I do want to talk about at a high level, and I hope you will take a look at on your own, is how to better take advantage of these runtimes and how they work with the Kubernetes ecosystem. In particular, how do things like liveness and readiness probes work with Jakarta EE and MicroProfile runtimes, specifically taking advantage of things like MicroProfile health and MicroProfile metrics. And how do these things work in a, let's say, Kubernetes native way of doing monitoring, in particular using Prometheus and Grafana. I won't have time to cover that in great detail. In fact, I may not even have time to demo it. But what I do want you to do is go and take a look at that. And that works fairly elegantly as well. So in fact, these APIs are designed to work well with things like Kubernetes and Grafana, and in general, the Kubernetes native ways of doing things like monitoring and observability. Finally, your CI/CD pipeline will look a little bit different than what it would look like without Kubernetes. If you're running on, for example, OpenLiberty or WebLogic or Payara or any other Jakarta EE and MicroProfile runtime, on VMs or on-premise versus the way they look like in Kubernetes. So in Kubernetes world, ultimately your deployment target is Kubernetes rather than bare metal, and that will change the way you do deployment a little bit more. There'll be Docker in the picture and things like Docker registries in the picture. So again, there's an example of all of that in this workshop as well. I'm fairly sure I won't have time to show you that other than simply talking about it at this moment, again, in the hopes that you will take a look at this by yourself. Now, for the demo purposes, in fact, we are expanding our partnership at Microsoft so that all of the Jakarta EE runtimes work equally well in the same way that I'm showing you in a demo today. But for the purpose of the demo, I have to pick one runtime. So the runtime I am picking is Webster Liberty, but this 80-90% of this applies to any Jakarta EE or a MicroProfile runtime. In fact, I'll be using Postgres as my database, but you can use any database if you like, whatever database you like. This talk, it will be using the Azure Kubernetes service, but majority of what I'll be talking about is not specific to the Azure Kubernetes service. They apply to any Kubernetes environment, perhaps even one that you are running on-premise yourself, or even if you're running Kubernetes locally using Minikube on your own laptop. And I'll be using Azure DevOps pipelines. This is a Jenkins equivalent that is Azure native, if you will. But again, most of the stuff that's in the DevOps folder could be equally translatable to a Jenkins environment as well. So without further ado, I've talked for quite a while. Let's go ahead and jump in and get started. The first step, as always, is to get things running locally on your own laptop. No fancy stuff. Really, those plain old-fashioned get your IDE running, get your JVM running, and get the thing up and running. So that is what I'm going to be doing next. In order to save time, I've done a little bit of cheating, but you can follow exactly what I'm doing throughout this talk, actually just by following instructions that are on the GitHub URL. So I have JDK 11 installed on my machine. I have Eclipse IDE installed. Again, you can use whatever IDE that you want. The main thing is support for Maven, and that's really all you need. I will be using Docker. I don't per se need Docker for this particular demo. I could have installed Postgres locally and demo that, but Docker is a bit easier. So I'll be beginning using Docker, and besides, we'll need to use Docker anyway when we get to the Kubernetes portion. So might as well get that started now. And of course, you will need this source code. So I have the source code downloaded on my machine. So the first step is to get the database up and running. Again, I'm going to be doing that through Docker. I don't assume that you know any of this stuff, frankly. So if you're a newbie to Docker and Kubernetes, don't be afraid. I will be talking a little bit over the basics of all of these things as we go along. So I'm going to be running, instead of running Postgres natively, I'm going to be running Postgres through Docker. And the advantage of this is that I don't have a local installation of Postgres. I don't usually run it on Postgres on my machine. There's no reason for me to have a database up and running. So I'm going to just do it through Docker. Docker is really nothing much more than, if you can think of it, it's really a virtualization technology, or rather more specifically, containerization technology. But you can think of it as a virtualization technology just to get your own thinking and learning on-ramp. So I'm going to be running Postgres. That's what Docker run means. IT simply means interactive. So I'll be able to control, see, and shut down Postgres here, as opposed to putting it in the background. RM simply means clean up this image and clean up any existing image with this name. Don't worry about the environment variable that I'm setting. It simply says, hey, please accept anonymous users into this database. I'm giving the image a name with the -- name parameter, as you can see. So I can refer to this image name and running instance. If something were to go wrong, I'll be able to reference it that way. Don't worry about the -v parameter either. It basically is making sure that when I shut down this database, the data doesn't go along with the Docker image. And then finally, I'm running the Postgres image. This is basically running Postgres, and there's a Postgres image up there on Docker Hub somewhere, and I'm running that. The -p parameter is important. So one of the key things you'll be needing to understand is Docker networking. So all of these Docker images basically run in their own little mini network inside of my own machine. And I am not allowed to access that network unless I explicitly say something. So in this case, I am saying, please open on that small virtual mini network that is running on my own little machine, please open up port 5432 and route it to my Postgres instance. So that's what that -p parameter is all about. So I'm able to say localhost port 5432 and be able to resolve to this Postgres instance. So I'm going to go ahead and run my Postgres instance here. Okay, Postgres instance is up and running. Now I can begin to go ahead and use it. I'm going to pop back into my IDE. I've simply imported my application into my IDE. Again, the step-by-step instructions to do all of this. So there's step-by-step instructions to run the instructions. So I'm simply cheating and going ahead, if you will. So I've imported this as a Maven project. I've also set up OpenLiberty on my machine. So now I'm simply going to do a Maven clean. So run as Maven clean, and that just makes sure everything is fresh and ready to go. And now I'm going to just run this application and show you how the application looks like. We won't be talking about the application code too much. I'll just briefly show you the code here, but we won't dig into it too much. This is just a vanilla Java EE application. It's representative. It's a CRUD application. It uses majority of the Java EE APIs or Jakarta EE APIs that you would use normally. And it has no external dependencies whatsoever. It's I would say, a very typical Java EE Jakarta EE application. It simply has a dependency on Jakarta E8. So let's go ahead and build this guy. So run as, and we're going to do Maven install. And I know Maven package and etc., but we're just going to keep things simple. So the build has succeeded. So I do have a WAR file. And in fact, we'll be using this WAR file throughout the application, the one that we're just building right here. But here's the WAR file that is already generated. So now I'm going to simply run this application. Okay, and it's a fairly fast startup. Liberty is no slouch in terms of being able to start up quickly. So this should start up really within just a few seconds. Okay, and this is my application. It is started up and ready to go. I don't particularly like the built-in browser in Eclipse. I don't use it much. It doesn't resolve in particular CSS that well. So we're just going to take this application and put it on the browser. So there's the application. Again, simple CRUD stuff. I'll just remove an entry here. I'll re-add another one. And there we have it. So this is just the application up and running. It's a simple CRUD application, and that is really all there really is to it. It's not terribly exciting. So we're really done with the local running. I just want to get you to a baseline comfort level before we move on here. So just shut down the database. In fact, I'm going to shut down the IDE as well, just to keep things a little bit crisp on my machine and save a little bit of memory. We don't need the IDE for the rest of the presentation here. All right, so that is getting things up and running locally. Now, what we're going to do is go and put this application on the cloud. And in particular, we're going to be putting it on, as I mentioned, Azure in this case. And we're going to be showing you how the traditional notions of clustering, so all of those things things like server administration and auto scaling, auto discovery, how all of those things work, and they work slightly differently than they do on premise. But again, the app servers have done a good job of adopting and adapting to this new world, if you will. So we're going to go into the clustering folder here and begin to do our work. So before I do that, I'm going to log on onto the Azure portal. So this is your Azure cloud experience, if you will. I'm going to log in as myself. And what I'm going to show you here is that I've cheated a little bit, and I've created a few resources ahead of time. So if I go into this resource group, which is roughly a translation of a data center, if you will. So in this environment here, let me minimize some of these things so you can see it a bit clearer. And I'll increase the font a bit too. Okay, all right. And actually, increasing the font in this case is not helping. So I'm going to keep it the normal font. So there's two different things I've created. One is, as you can see, is a Kubernetes, Azure Kubernetes service instance. This is a managed version of Kubernetes that is already up and running. And I've also created a Azure PostgreSQL server. And that is a managed server, again, a managed database offering on Azure. So this is the equivalent of the Docker command that I ran in order to get the database up and running locally. In this case, the database is up and running on the cloud. And again, all of these things are documented, and you can see how to set all these up if you follow the instructions. So you can set up the Postgres instance, you can set up the Kubernetes cluster, and I've also set up kube control. If you haven't seen kube control before, I will show you just in a moment. But basically, this is a command line to talk to Kubernetes. When you're working with kube control, it'll almost seem like, hey, this is Kubernetes is running locally, when in fact Kubernetes is actually running remotely on Azure. But this gives you essentially the feel for interacting with Kubernetes, interacting with your cloud vendor, almost as though it's something that is you're only doing through a local CLI. So let's begin a simple introduction of kube control. So I do have kube control set up here. So we're going to do get pods, or rather, let's start with get nodes. What you'll see is that there's three what is called nodes. You can think of this as a ready set of virtual machines ready to go. They're ready. You're ready to deploy stuff on them, ready to deploy containers in particular on them. So there's three of those. So we'll also do get pods, and this will tell us that there is no pods currently available, right? So I haven't deployed any pods. And pods you can think of as real running things, real running images on Kubernetes, and I don't have anything deployed. So that means this is basically a clean installation right at this moment. And also we'll do get services. And you'll see that the only thing running on this Kubernetes instance right now is simply Kubernetes itself. And it is running it now on type cluster IP, which means Kubernetes is only accessible from within the cluster. So it does not have a external IP, as you can see here. So let's go ahead and begin deploying our application and see what happens. So in order to deploy this application, the first thing you'll need to do is configure something called ingress. The reason for this is I'm going to enable, in this case, the admin console for Liberty to show you how the admin console access looks like in a Kubernetes environment. So in order for me to do that, I need that application is actually a stateful application. It is not a stateless application. And I will need sticky sessions for that. So sticky sessions are, by default, you can use something called load balancing service on Kubernetes, but typically those are not capable of sticky sessions. So if you want to use sticky sessions like I am going to use in a moment, you need something called ingress, and ingress you can think of it as a real load balancer, a real gateway. So I'm going to be using Nginx as my ingress controller in this case. So first thing I'm going to do is create something called a namespace, and what this allows me to do is sort of isolate the setup of Nginx into this namespace. So I'm going to go ahead and create the namespace. So kube control, create namespace, ingress basic is what I'm going to call it. So I've created error already exists. Okay, so so I already have the namespace created. I'm going to go ahead and delete it to make sure there is nothing conflicting. Okay, so I'm going to go ahead and issue a delete command to clean that up. Okay. All right, and hopefully while that is going on, we're going to get the ingress controller. Pardon me. So this will take just a moment, hopefully not too long. Okay, so while that is going on, let me show you a bit about what we're going to be doing next with some of this. So here's the ingress controller. I'll be creating the ingress controller. Then I'll be using something called Helm, which I have installed. Helm is a package manager. You can think of it as sort of NPM for Kubernetes. So we're going to install Nginx through Helm. And then we're going to install essentially Nginx itself. So that is what this command is about. I won't show it to you in great detail, but think of it as basically installing Nginx on that Kubernetes cluster. And then finally, once that is all installed, we are going to check to see what IP address we get out of this Nginx controller. In other words, what is our gateway IP address, and we'll do that through this Git services call, as you'll see in just a moment. So hopefully our deletion is not taking too much longer. Okay, hopefully we don't have any hanging resources. Okay, while that is going on, maybe we can move forward a little bit. Let's go on to the next step here. So after I create the Ingress controller, next step for me is going to be basically building the application itself. So I just did a fresh build of the application. This is what all this is about. So this is about getting a copy of essentially the WAR file. So we're going to go ahead and copy over the WAR file. So I'm going into my file system, going into GitHub, going to Kubernetes, and I have it in the WAR file right here. So we'll go into the target directory, copy over the WAR file. And I'm going to copy it into this clustering directory, and that's where we'll be at in a second. So I'll just take paste, and yes, there's a file by that name already, and that's okay with us. Okay, so now we can get back to we'll return back to this again, but remember that we just copied over the WAR file. So we're going to go ahead and create the namespace. Okay, so the namespace is created. So now I can safely install my artifacts there in that namespace, as opposed to in the namespace that I'm going to be deploying the application to in a moment. So we'll add the repo. Okay, that's added. Then we're going to install. Go ahead and install the gateway by installing Nginx. And that won't take long. Okay, so that should all be created at this point. We're going to go see if we can retrieve this now. Okay, and you can see that the external IP is already out there, right? So if I go ahead and try this external IP now, I'll probably get a 404 because there's nothing to see right at this moment. Yep, Nginx is saying 404, no problem there. So next up for us is going to be building the image, building the WAR file, which we already did in just a moment. And I'm going to do a Docker login because what we're going to do next is essentially build an image, right? And we need to ultimately get that image onto somewhere where Kubernetes can access it. So we're going to do a Docker login, and we're going to do that by pushing my image onto Docker Hub, essentially. So, okay, so now the next step for me is going to be building an image. So let's do that. And this is what this command in fact does. So I'm going to, the syntax of this command is basically docker build and give it the name of your image. I'm going to have to prefix the image name with my Docker Hub account, which is Reza Rahman. Give the image a name, Jakarta EE Cafe, and give it a so-called tag or version. So just to be sure, I'm going to be using 101. This is a tag I haven't used before. So I'll go ahead and build the image. Okay, so image build is going to be relatively quick, but as that is going on, let me just show you how my Docker file looks like. So this is how my image looks like in particular. So I'm starting from Liberty kernel. So this is a very minimal installation of Liberty. Then I'm going to install a Postgres driver. I need that to talk to the database. I need a server XML configuration. I'll show you the server configuration in just a moment. And then finally, I'll be copying over my WAR file and then invoking configure.sh. Configure.sh is a very interesting capability and an optimization for Docker that's built into Liberty. Basically, what this does is it provides a super optimized installation of the image, if you will. So the image is going to be created, and here's the server.xml. In the server.xml, I really have just a few dependencies. I'm using Java E8 or Jakarta E8. It's the same thing in Liberty's case. I'm using session database because I'll be actually using session clustering by the session database, and I'll be using the admin center as well, just to show you how the admin experience looks like on Liberty. And you'll see the rest of the configuration. It's relatively straightforward. It's mostly just configuring those components. So let's see if my image is built. Okay, the image is getting built in just a moment. Okay, maybe as the image is getting built, I'll dig in a bit more into how clustering is looking like in this world. So we are creating a fully cluster capable application server here. So as you can see, this is a database configuration. And you'll see where the database configuration comes from. I'm actually pointing to my database instance on Azure. And then we do have the session database configured here. It is pointing to the database. I'm using the database both to store the sessions as well as to store the data, my application data as well. Okay, so after the image is going to be built, I'm going to be pushing the image onto Docker Hub. And you do that through the Docker push command. And the reason you need to do that is remember that Kubernetes is running on my data center on Azure. So Azure does not have access to my local machine, right? So I need to push this image out onto somewhere in public. Now you can use Azure Container Registry, or you can use it something like Docker Hub. Since this is just a demo, I'm keeping it simple and simply uploading it to Docker Hub. So we'll do that shortly here. Okay. All right. Sometimes the configure.sh takes a little bit longer. For some reason, this seems to be taking a bit longer than what I was expecting. But because of Docker layering and caching, this usually is not a big deal. It's just the first time that takes a little bit longer to build the image. So the image is now built. We're going to push the image now. Okay, and we're going to tag it V101. Okay, so let that go on, and our next step is going to be actually deploying this image, deploying this entire application onto Kubernetes. And the way we do that is by using a deployment descriptor, if you will. It's done in YAML, and I'll show you before I issue this commit. I'll just show you how that actually looks like. So if you go to the jakartaecafe.yaml file, this is how the deployment looks like. So this is a type of deployment. And the main gist of this deployment element is that I'm specifying what image I want to be using. And in fact, when I open up a local file, a local version of this file, you'll see that I've appropriately changed the value of this. And I've also appropriately changed the value of these environment variables that are defined here. And they're pointing to the database instance that I'm running on the cloud. You'll also notice that you can specify how many instances you want. So in this case, I'm running 2 copies of it. So this is a basically high availability situation. So this is using 2 replicas. And then you do finally need a service in order to expose these. So think of this as an internal load balancer. So this is using cluster IP, and it's doing, by default, OpenLiberty runs on 9080 and 994. So I'm doing port forwarding on port 80 and port 443. And finally, I'm creating an ingress, right? And the ingress is where the cookie handling is going to take place. And you'll see that in a moment, how I'm doing cookie handling so that I can log onto the admin console properly. And again, not doing much port forwarding here. I'm simply saying that the service port is port 80 and port 443. So this is, believe it or not, all you need to do. In a on-premise environment, you need to do a lot more configuration in order to get application server clustering up and running. But in this case, you don't need to do anything at all, because Kubernetes is doing majority of the heavy lifting for us, including the load balancing handling as well. And in fact, you can set Kubernetes to auto scale this cluster. So you can also manually do it through the command line as well. Using something like this to scale your replicas up and down. So all of that clustering and load balancing and deployment is being handled by Kubernetes. It is not handled by the app server. Okay, I think we're going to be doing okay, and we'll be just about on time. After this, I'll show you how this differs with the operator, and we'll talk about the operator in just a second, and we'll finish up our session here fairly shortly. Okay. In the meanwhile, I'm just going to get put my can't do that at the moment. We'll get the ingress controller IP address and try to re-put the ingress controller IP address in one more time. Okay, so the push should be almost done now, so we can get ready to do the Kubernetes deployment. Okay, that is done. We're going to issue the deployment command, and that should be relatively quick. However, it's not as quick as you might think. So we're going to, remember we did the kube controls commands before. So now let's do get pods. Rather, let's do services first. Okay. You'll notice that now we do have the Jakarta EE cluster IP internal load balancer configured as well. And we're also going to do pods for a second, but we're going to watch the pods. Okay. So both of the pods are actually up and running at this point. So actually, there's not much to watch. That was surprisingly fast. So they're both, as you can see, both of the machines running the application are up and running. So we do have it and ready and running status. So actually, we're mostly ready to go at this point. So what we're going to do is we're going to get the ingress next, and we're going to see the application up and running. Okay, and that is the ingress address. So we're going to go ahead and open that up. And this time we should see Open Liberty, and we do. We'll take a look at the application itself. That's called Jakarta EE-Cafe. And there's the application. I had some data in there. You can see the data. And now we're going to take a look at, so all of the load balancing and sticky session handling is working. So now we're going to take a look at how we can administer this application as well. And we can do that through the admin center that I have enabled. So we're going to just ignore this. This is because of self-signed certificate. And our admin name and password is fairly simple. It's in the super secure server.xml if you want to take a look at it. And here you can begin to see all kinds of information about our runtime, including monitoring capabilities. And obviously, this is much stronger when you take a look at the Prometheus ends of things as well. But you can at least see some basic information about each of the pods here as well. And in fact, if you go into the portal will tell you a bit of information about the running Kubernetes cluster as well. So we'll take a brief look at, I'll show you briefly how that looks like. So here's our resource group. Here's the Kubernetes cluster. And here are some information about the cluster itself. So you can take a look at it this way as well. So either way. So this is giving you cluster level information. That is giving you server level information. So that is how you can do a load balancing and administration of the server in a basic way. Now, that is all the time that we have, unfortunately, right at this moment. So I'm going to just talk about the Liberty operator, and we're going to finish up our session here today with that. So it is mostly just the same, right? So pretty much everything else will look the same. As you'll see in the instructions when you go through them, we will install something called the Liberty operator. So in the setup that you saw before, each of the nodes actually do not know about each other. They do not directly communicate. So in order for those nodes to directly communicate in a application server native way, what you need is another piece called an operator. So you install the operator and you do the deployment through the operator. And almost every single application server now actually does have this notion of an operator that allows application native clustering in a Kubernetes friendly way. And you'll see a big difference when you take a look at the way the application is actually deployed, right? So you'll be deploying a kind of open liberty applications, not a type of deployment. And you'll see that when you compare both of these deployment files, this one is significantly simpler. It's because the operator is doing the deployment rather than Kubernetes doing the deployment. So the Kubernetes is still involved, but the administration and some of the cluster coordination is being taken over by the application server operator, and you'll still see that the same type of administration, upscaling, downscaling, all of that will work exactly the same way. And even in this case, there will be an ingress control. Okay, so that is about it. I hope I gave you enough of a feel for how you can effectively use Kubernetes and use application servers and use Jakarta EE and runtimes and MicroProfile runtimes with Kubernetes, in this case specifically with AKS, but in general with any Kubernetes cluster. So really appreciate it. I hope you have some fun, and I hope you learned something and this was useful.